you get this one? What'd you do?
I have minus 36.
Yeah. Oh yeah, I did. You read. Like that? And let's go to that.
That moves the x
What
squared.
we did is
And I took out my 36.
Now you can just set the top and the bottom equal to 0.
Do anything else like that?
Yeah, just find the critical point. So you set the top and
Oh,
bottom
zero.
equal to 0. Just I have a question, just real quick.
Mm-hmm.
So I got 36x squared minus 36. Would it be better to take out the 36, or would it just be better to
Since it doesn't have an x with it, it doesn't matter on that. You don't want to ever divide by an x and cancel that out because that'll usually cause you to lose a number. But since that 36 doesn't have an x with it, you could do it either way. It'll be fine.
plus minus 1, and then
The next one is square root of negative 3. But when you do square root of negative 3, you get plus or minus 3 or plus 1.
negatives under the square root means it's imaginary, right?
Correct.
Okay, so
Correct.
it doesn't count. as
Right, you don't get a point from that. Very good.
The only ones that we have is one negative, right?
How does Will Blackburn do the standard?
No. He has gone back to just being, I guess, on patrol. So it's Officer Trexler, but they look a lot alike.
Was he the
They
guy
really
with
do.
the more blonde beard? Or like the taller guy?
Honestly, if they didn't have their names on their uniforms, I couldn't tell them
They
apart.
had one with glasses, they had one with like lighter hair, and then they had this one with darker hair.
Yeah. So I'm not sure which one's which, and there's a chance that one of them, like Blackburn might still come fill in some over here. But Officer Trexler is the one that's assigned to us now. Actually, I think he got a promotion. Yeah. So. No, it's not him. Let's see. You have made one grave error. Everything was pretty good, right? Except. Yeah.
So you only put points 1 negative 1 on your number line.
Huh?
Yeah.
He's pretty good. Yeah, he's pretty good. Although he did roll in about 5 minutes late this morning. Well, more like 2 minutes late. He said he woke up at 8:10 this morning. Yeah. If you guys have it, here is what I have.
Because negative 1 and 1 would be equal to
So you should get 36x squared minus 36 over x squared plus 3 to the third for your second derivative right here. Does that look right? Double check me because I've been faltering today. And then you will set numerator and denominator equal to 0. On this side, you'll move the 36 over. You'll divide by 36 to get the 1. And you will square root both sides, which will produce a plus or minus 1. there. So you'll have 2 critical points here. And then over here, whenever you try to do this, you end up with a negative underneath the square root, and you will not get anything from that. And if you want to kind of like start understanding, like seeing that that's going to happen, you have a x squared, which is positive. You're adding 3 to it, which makes it even more positive. And then you're raising it to a power, positive number to a power is still going to be positive, right? So this is never going to equal 0. So you can also just kind of notice that and not necessarily work this out over here if you want. So we will put -1 and +1 on our number line. And then you're just picking a number to plug in each section. I really just looked at the numerator because the denominator is always positive, right? Using that same reasoning. This is always positive. So the second derivative here, if we plugged in like -2, 36 times -2 squared minus 36 is going to give us a positive number. But if we plug in a number like 0, we will get a negative here. And then anything bigger than 1 will also give us a positive. And so, since our second derivative is positive, f of x would be concave up. From -infinity to -1, from -1 to 1, you would be concave down, and then concave up again from 1 to infinity. Because I want to make sure we got time to go through the FRQ and stuff, I'm not going to write out the explanation for that right now, but you would need to if this were a free response question. Okay, everybody good here? All right. Let's see. We got to go over FRQ. What do we have time to do? I'm going to skip 3. It's going to be a double. You're going to have to do quotient rule twice, and you can do it. I believe in you, but I'm going to skip ahead because I do want to make sure we got plenty of time for that to go over at least one of those FRQs. So for 4, let's do one with some trig. This is a pretty easy derivative because it's just basic trig. So f prime is going to be negative sine x minus cosine x. And then you got f double prime of x, which is going to be negative cosine x plus sine x. So if we set that equal to 0, we don't really have an equation that we can solve. But if I move that cosine over to the other side, I'm looking for sine x to equal cosine of x. And there are only 2 places on the unit circle where sine x equals cosine x, right? So on that unit circle, they have restricted us to 2 pi, 0 to 2 pi, which they will normally do, because if they do not do that, then this is going to be infinite. Like it's going to go on and on and on forever. So they normally do this. Where on the unit circle between 0 and 2 pi does sine equal cosine? Yep, right here at pi over 4, we got root 2 over 2, root 2 over 2, and then, no, 5 pi was right. 5 pi over 4. Negative root 2 over 2. Yeah. Negative root 2 over 2.
Is 7 pi over 4 is the fourth one?
Yes. Yeah. Think of reducing like 5/4 would be a little bigger than 1. So it's a little bigger than 1 pi. So it has to be that third quadrant. Okay. So we get x equals pi over 4 and x equals 5 pi over 4 are going to be our critical points, our super critical points here. So if we make ourselves a sine line for our second derivative, I'm going to put 0 and 2 pi at the ends because we don't really care about looking outside of those. And then we've got pi over 4 and 5 pi over 4. Whenever I'm trying to think of values between 0 and pi over 4 and pi over 4 and 5 pi over 4, I think about my unit circle, right? So if we're looking from 0 to pi over 4, that's this section on the unit circle. You've only got one value that falls in that category. What would that be? You only have one value that will fall in this segment of the unit circle. It would be pi over 6, right? And at pi over 6, we should get root 3 over 2, 1/2. So if I'm plugging into my second derivative, it would be negative. See, cosine is your x coordinate, so it's negative root 3 over 2 plus 1/2 is what you would get for negative cosine plus sine of pi over 6. So is that going to give me a positive or a negative?
Negative.
It's negative because square root of 3 is bigger than 1. So you're going to get a negative there. Then when I look at pi over 4 to 5 pi over 4, I'm thinking about this part of the unit circle. I would pick one of the 90-degree increments, like pi over 2 or pi. Let's go with pi. And at pi, you should get negative 1, 0. So if I'm doing the second derivative, I'm doing negative cosine plus sine. So it's going to be negative 1 plus 0. And that will give us a positive right here in the middle. And then this last part right here corresponds to this section of the unit circle. Again, I am going to use those 90-degree angles anytime that I can. So this right here would be at 3 pi over 2. And the coordinates there are 0, negative 1. And so for that segment, you would have negative cosine, so negative 0, plus sine, which is negative 1. That's going to give you negative 1, so it'll be negative there. Everybody okay here? Which segment is where we are concave up? Pi over 4 to 5 pi over 4. So we would say that F is concave up for pi over 4 to 5 pi over 4 because F double prime of X is greater than 0 or is positive for that interval. Okay, questions? Okay. 5 is a difficult problem, but we can make it a little easier than it initially is. Because right now, if you do it as it is, you've got the natural log on the outside. Then you've got the square root on the inside of that. And then you've got the x squared plus 4 on the inside of that. So that would be a triple chain rule. And those are not super easy to do. But there is a way around it using some properties of logs. So watch this. I'm going to write this as x squared plus 4 to the 1/2 power. Does anybody remember what we can do with that exponent when we're doing properties of logs? We can move it out front. So we could make this 1/2 natural log of x squared plus 4. Okay, that will make it easier to take the derivative of, because now the 1/2 is just the coefficient. We don't have to do a double chain rule. It's just going to be like a single chain rule that will be a lot easier. So, so when we take that first derivative, I'm just going to leave the 1/2 out front, and then when we take the derivative of natural log, this is one that we've been struggling with a little bit. It is 1 over the stuff on the inside. So put yourself a dot right here. This is multiplied. Do 1 over stuff on the inside, x squared plus 4. But then you must multiply that by the derivative of the inside. What would the derivative of the inside be? 2x. Notice how I kind of wrote that in the top, because I need these to all be fractions so I can simplify. And 2x is multiplied over here on the end, so that's like 2x over 1. So that will give us 2x over 2 times x squared plus 4. Make sure you got parentheses around that x plus 4. And these 2's can cancel each other. So we will get x over x squared plus 4. Or if you leave the 2's, you'll still get it. It will still be right. It'll just make the numbers a little bigger when you take that second derivative. Okay, questions here? So now we need to take a second derivative. What are we going to have to use to take that second derivative? Quotient rule. So we are going to have x squared plus 4 times the derivative of the top, which is 1, minus the top, which is x, times the derivative of the bottom, which is 2x, all over x squared plus 4. And we'll want to simplify that a little bit. Yes. X squared plus 4 minus 2x squared over x squared plus 4 squared. And that is going to give me 4 minus x squared over x squared plus 4 squared. Okay, questions so far? Alright, we want to set the numerator and the denominator equal to 0. Is the denominator ever going to equal 0? No, because you have a square, you're adding something to it, and then you're squaring it again. It could not possibly be, I mean, it's got to be positive. It's like 3 different things that you're doing to it that make it positive, right? You square something to make it, if you started with negative, you would square it, it would now be positive. You'd add 4 to it, it's positive and a little higher than it was. Then you square it again, so it's definitely positive. So I wouldn't even consider the bottom. I just worry about the top. So 4 minus x squared equals 0. So 4 equals x squared. And then you will square root both sides to get the plus or minus 2 for those points. And for this one, again, that denominator is always positive, so you really only care about the numerator. So if I'm plugging in numbers like -3, 4 minus -3 squared is going to be 4 minus 9, and that'll give me a negative right here. A number between -2 and 2, like 0, would give me a positive, and then a number bigger than 2 would give me a negative. Okay, so we should probably write a conclusion. Oh, actually, let's write a conclusion for this, because this was a different question. We haven't answered one of these yet. It did not ask for concavity. It asked for points of inflection. So if we're explaining a point of inflection, it's a little like explaining the maximum or minimum points. You don't want to talk about positive or negative. You want to talk about changing signs, right? So we would say that F has points of inflection at x equals -2 and x equals +2 because f double prime of x changes signs at these points. Questions? Alright, let's do the E ones because I think we get mixed up on those two. E's are like the easiest derivatives we can have, but yet somehow pretty difficult because we forget what to do with them. The first thing I would do with this problem is I would rewrite that exponent because right now you've got -2 over x as your exponent, like that. So I would rewrite that as e to the -2 x to the -1. And this is still f of x. I've not taken the derivative yet. Okay, it is going to make it easier to do the chain rule on that problem because when you do this problem, you've got to take the derivative of the outside, which is exactly itself, e to the -2 x to the -1. But then you must multiply by the derivative of the inside, which is the derivative of your exponent. So for that, we would get +2 x to the -2 power. And so if we want to take a second derivative, you've got some options here. You can use a quotient rule, or you can just use a product rule. I think I'm just going to leave it like it is and use a product rule for this one. So when I take this second derivative, I will have e to the -2x to the -1 times the derivative here, which is going to be -4x to the -3 power, plus 2x to the -2 power, times, we've got to do the derivative of e to the -2x to the -1, which is just all this stuff, right? Because we're doing the same thing again. The derivative of the e part is e to the -2x to the -1, times the derivative of the exponent, which is 2x to the -2. Okay, here. All right, I would notice that these two right here are the same, and I would factor them out. So that would be e to the -2x to the -1 times, and here I will have -4x to the -3 plus 4x to the -4. Every piece does have it because this stuff right here is multiplied together. And then you got a plus sign, and then this stuff right here is multiplied together. So if you had something that was like a plus 2x and -2, then you wouldn't be able to factor it out. All right, let's see. What do I want to do here? You got several directions that you could go. I would probably, at this point, I would probably look and see these both have x's right here, and I would factor out x to the lowest exponent. So out here with my e to the negative 2x to the negative 1 power, I'd put an x to the negative 4. And then when you do that, when you take out an x to the negative 4, that second term's a lot easier. The x to the negative 4 just cancels. What's going to happen here when I do x to the negative third divided by x to the negative 4? You subtract your exponents. 3 minus negative 4 just gives you 1. So you'll have negative 4x plus 4. And then I would do this, negative 4x plus 4. I would move anything with a negative exponent back down to the bottom. So that would give you, this is a little tricky right here. It's going to be e to the 2x to the negative 1. The negative exponent on your little x doesn't change. It's just that sign of the overall exponent. And then you'll have x to the 4th. If you want, you could write it back like this. 4x plus 4 over e to the 2 over x times x to the 4th. Alright, what do we do once we finally get that second derivative? Very good. Set top and bottom equal to 0. Part of it can. Alright, e to the 2 over x times 4 equals 0. So these two things are multiplied together, right? Which means if either one of them were 0, it would make the whole thing 0. So that means e to the 2 over x, if it equals 0, you would get 0 in the bottom, and x to the 4th equals 0. Is e to a power ever equal to 0? It is not. So you won't get anything out of this. But what about over here for x to the 4th? That's going to give you 0 because you can just 4th root both sides for that. And then over here, you would have 4 equals 4x, and you would divide by that 4, and 1 equals your x. So we get 1 and 0 as our critical points. I probably would make a chart on this one. It's negative 4x plus 4. I would do e to the 2x and x to the 4th. Actually, I don't know if the chart's so necessary, now that I think of it a little bit more. Because e to the 2 over x, what's its sign going to be? It's positive everywhere. What about x to the 4th? It's also positive everywhere, because much like squaring something, if you raise something to an even power, it's always positive. So I probably could have left that off right there. It's not entirely necessary. So if I plug in something negative, I will get a positive. If I plug in something between 0 and 1, like 1/2, I get a positive. And if I plug in something bigger than 1, like 2, I will get a negative. And so I got positive, positive, negative. And what did it even ask us for? Concave down. So if we want to know concave down, we would say F is concave down for 1 to infinity because F double prime of x is negative on this end. Okay. It is very much like the increasing, decreasing, maximum, minimum stuff. You're just looking at the second derivative. And it's very much like those problems as well, is that the difficulty of them depends on how difficult it is to take the derivative. They're pretty easy if they give you a problem like my first example. They're pretty difficult, like the one that we just did where the derivative is a lot more difficult. So let me look at what you got there. Let's see. 242. We can cut this back a little bit. Let's see. 10 is very similar to 6. I'm going to take it out. I got some more trig down here. 13 is a lot like 3, so I'm going to take it out. Leave 18. I'm going to take out 11. Leave 1, 2, 3, 4, 5, 6. Okay, I think that's reasonable. There. The first two are asking for concavity. The last four say to discuss concavity and points of inflection. You can just do points of inflection on that. It all requires pretty much the same work. The only difference is in your conclusion there. I definitely don't want you to have to write out all the concavity conclusions and all of the point of inflection conclusions there at once. Okay. All right. Let's look at one of the FRQs for this week. So. The response. Which week are we even on? Is it 9?
Yeah. Assignment number 9.
Alright, my solutions too. Which one do you guys want to look at? 2.
The K really confused me, but 2 was really difficult.
Okay. Yes. Yeah. All right. Let's do the second one here. All right. So, this problem gives us f, and it also gives us f prime, so we don't have to find the first derivative. So for a, when it asks us to write an equation for the line tangent to the graph of f at x equals e squared, we're not going to have to find a derivative. They've already given it to us. So if we want the point, what have we got to do to find the point? Plug into the original. So we're going to say f of e squared is going to equal natural log of e squared over x. And what do a natural log and an e do to each other? They cancel. So you're going to have 2 over x. Oh, yes. Thank you. What? Yeah. It is e squared squared. So that gives e to the 4th. Thank goodness you guys are paying attention.
Wait, not for the derivative.
Oh, okay, you're right. Oh, I'll let you trick me.
What did you do that on purpose?
He's just trying. He knows I'm off today. He's just trying to make me fall apart up here. Okay. All right, so our point, it's ugly, but it is. The x-coordinate is e squared. The y-coordinate is 2 over e squared. And then we need to find the slope. How are we going to find the slope? Plug it into f prime. So f prime of e squared is going to be 1 minus natural log of e squared over e squared. Here's where we've got the e squared squared. Okay. Natural log and e cancel each other out. So I've got 1 minus 2 over e to the 4th, which will give me negative 1 over e to the 4th. So that is my slope. And then this is ugly for our tangent line because we got all of this e stuff, but we must remember e is just a number. So we've got y equals, our slope is negative 1 over e to the 4th times x minus e squared plus 2 over e squared. And that's it right there. Don't try to simplify. It would some, but it wouldn't be worth it. Okay, questions? All right. B asks you to find the x-coordinate of the critical point of f. Determine whether this point is a relative maximum, a relative minimum, or neither for the function f. Justify your answer. So this is worded like there's only one, but I do have a numerator and a denominator in my derivative I need to set equal to 0. I need to do that just to make sure that I'm not missing something here. So if I do 1 minus natural log of x equals 0, I could move my natural log of x over, and that'd be 1 equals natural log of x. And then how do I get rid of the natural log? E to the power. So x equals just e there. And then I also have my x squared equals 0, so this gives me x equals 0. Why did they act like there's only one critical point? X has to be greater than 0. So while this does meet the criteria for a critical point, it is not going to be one that we consider because we're only looking for x greater than 0. And because this function relies on natural log, you cannot take the natural log of 0. So it makes sense, that's just not in the domain for this. So for our sine line here, because we have to tell whether we have a maximum, minimum, or neither, I'm going to put a 0 right here. We don't want to go below 0 because that's not in our domain. E would be over here. So I need to find a number between 0 and e that I can plug in. One of the problems here, this is not a calculator active problem. All right, so e is 2.7 something. So 2 would work. But if I plug in 2 over here into natural log of x, does anybody know off the top of their head what natural log of 2 is? You do not, right? That's like a decimal that we don't have memorized. What number would work that we should know? 1. 1 will work right here. So if we took 1 and plugged it in, f prime of 1 would be 1 minus natural log of 1 over 1 squared. And what is the natural log of 1? It's 0. So that just gives us 1 over 1, which is 1. So that is positive right there. All right, now the second part, I have a feeling that it probably switches to negative. That's what usually happens. But we don't want to make that assumption because it could do something different. So I need to plug in something bigger than E. But I know like 3 or 4 or 5 or 10 would all be bigger than E. But do we know the natural log of 3 or 4 or 5 or 10? No. Any ideas of what we could try right here?
I already found the derivative of E squared. You could use E squared.
Okay. E squared is an excellent idea because E squared is bigger than E, right? So we can do f prime of E squared. And as Tyler said, we already found that up here, right? And it was negative 1 over E to the 4th. And that is going to be a negative value right there. And so we could say that f has an, a relative maximum at x equals E, because f prime of x switches from positive to negative. At that point. Okay. Yes. Natural log of 0 is undefined. And it does tell us x has to be greater than 0. That's also another reason for that. Okay, we good here? All right, now, f has exactly 1 point of inflection. Find the x coordinate of this point. So, point of inflection, we just learned this just now, so even if you did already look at this, you didn't know how to do this part, we need to find second derivative. So, f double prime of x, we're going to have to use the quotient rule for this. So, we would have low, which is x squared, times the derivative of the high, which is the derivative of 1 is 0, and then you'll have negative, what's the derivative of natural log of x? 1 over x, minus high, which is 1 minus natural log of x, times the derivative of the low, which is 2x, all over x squared. Now, right here for this first part, you got x squared, that's like x squared over 1, and you're multiplying it by negative 1 over x. So what can happen here is like this x can cancel with one of those x's, and you will just get negative x, which is kind of a relief because now we don't have that complex fraction anymore. And so if we're looking for critical points here, we could set numerator and denominator equal to 0. What are you going to get when you set the denominator equal to 0? 0, and they told us to only look for x is greater than 0, so we don't want to consider that. So we're looking at the numerator there. Let's see. I'm going to distribute. So that's going to be negative 3x plus 2x natural log of x equals 0. Anybody know how to solve that? You might be tempted to move the negative 3x over to the other side, and then you could divide by the 2x. But that would be dividing by x, and the x's was cancel. Actually, it'd still probably be okay. Yeah, let's do GCF instead because it's a little bit risky to do that. It would probably be okay because the one you're going to lose is 0, and 0 is not an answer. But let's do a GCF instead. So we'll do x, negative 3, plus 2 natural log of x equals 0. So this does give you x equals 0. That's the answer you would have lost if you didn't do it this way. So it's really kind of okay if you do it for this problem. But there could be times that wouldn't work very well. So we got negative 3 plus 2 natural log of x equals 0. And so that's going to be 2 natural log of x equals 3. So natural log of x equals 3 halves. And then what do we have to do to get rid of a natural log? E to the power. So x equals e to the 3 halves. Now this is more than likely our critical point because it's the only one that we have. Or right, it's more than likely our point of inflection. But we have to give a reason why it is the point of inflection. So for e to the 3 halves, and we've got f double prime of x. So the denominator really doesn't matter for this because it is x to the 4th, and x to the 4th is always positive. So we don't really care so much about that. What value could we plug in between 0 and e to the 3 halves? We could use 1. You could use e, would also work well. Let's go with 1 though because it'll be the most simple. So if I plug in 1 right here, f double prime of 1 is going to be negative 1 minus 2 times 1 times 1 minus natural log of 1 all over 1 to the 4th. And so that is going to give me negative 1 minus 2 times natural log of 1 is 0, so I just get 1 here, and I get negative 3. I don't need the value, I just need to know that it's negative right there for that. And then, what could I plug in bigger than e to the 3 halves?
I forgot what e is.
E to the 3rd would work. E squared will work also. Really, e to any power bigger than 3 halves would work here. So let's use e to the 3rd or whatever. So if we do our second derivative of e to the 3rd, we will have negative e to the 3rd minus 2e to the 3rd times 1 minus natural log of e to the 3rd all over e to the 3rd to the 4th. I'm really running out of room here. So I got negative e to the 3rd minus 2e to the 3rd times, what is the natural log of e to the 3rd? 3. So you're just going to have 1 minus 3 right there. And that's going to be the key to knowing what we've got here. So we've got negative e to the 3rd minus 2e to the 3rd times negative 2. Gosh, I'm still running out of room. negative e to the third plus 4e to the third over e to the 12th. And that would give you positive 3e to the third over e to the 12th. You could cancel some e's there if you want, but are you going to get a positive or a negative here? Positive. And so I was not very generous with the amount of room that I left you here. But we would say f has a point of inflection at x equals e to the 3/2 because f double prime of x changes signs. At this point. Okay, I know it's about time to go. Let me just, this last part is really just visualizing what is happening here. F of x is natural log of x divided by x. Natural log of x looks like this right here. It has a vertical asymptote at 0. So if I approach 0 from the right, even if I'm dividing it by x, these are all positive numbers, so it's not going to change my sign. So as I approach from the left here, that limit as x approaches 0 from the right of f of x would equal negative infinity.